Hola, bueno, gracias, mi amigos. Es 5 de mayo. It's time for lección 86.2. We're gonna do a standard form for translation and scale changes. So welcome to today's episode. And we're gonna put it all together today. So as a bit of review, I want to point out a couple of things. First, in lesson 82, when we first introduced these wiggly sinusoidal curves and talked about the period of them, we were busy squishing it this way by adjusting the frequency or the period, and we stretched it this way when we tweaked the amplitude. So he gave you kind of the standard form for tweaking the amplitude or the frequency period. Either y equals a sine bx or y equals a cosine bx, where the absolute value of a is the amplitude, because what if it's upside down, right? The amplitude doesn't change because it's just the distance from the center line. And then we can tweak the frequency. If this goes to 3x, we know we get 3 times as many waves in 2 pi radians. Or if we want to translate it as what is the period, how long is one wavelength, we can go 2 pi, which is the standard length of a wave for sines and cosines. Now hear me. Sines and cosines is different for tangent, but then just divided by that frequency. So what if b was 2? Then we have that the period is only pi radians. You get 2 waves in 2 pi radians. That was lesson 82, where we dealt with those two aspects, vertical and horizontal dilation or expanding. And then in our last lesson, 86.1, we gave you these two equations for either sine or cosine. We were adjusting h, which is termed the phase shift or the horizontal shift, taking the entire picture and moving it to the left or to the right. And then the k part, which is the vertical shift, taking the entire picture and moving it up or down. These were translations, and these are basically scale changes. Okay? And what we're going to do today is we're going to put both of these equations together into one equation. I'm going to erase the board, so you might want to hit pause and get that data down. But we're going to give you all of it together, what's called the standard form. Okay? There's your chance to pause to clear the board. Menudo dice, put your hands up like this. Okay, here it is. Standard form. Put all the stuff in there. A, B, H, and K. Either with sine or with cosine. And this is like times. All right, all the things are like multiply. A sine B, parentheses, x minus h, and parentheses plus k. Or a cosine B, parentheses, x minus h plus k. So all 4 things are in there. And the fun thing is, if you just start with your sine x or your cosine x, you can start piecing out what did this equation do. Like what we are going to do here in example 4 is I'm going to start with the whole shaboogie, all the stuff that you could possibly do to it. It's all in there. And then what you might want to do is put it in your y equals and then actually sort it out first and then predict what's going to happen to the picture. So here's my method to my madness. Is given an equation like this, which is actually, they've done a pretty nice job of setting everything up just in its place. We just kind of relate the standard form to this and we say, what's A, B, H, and K? That's the first thing I do. I say, what in this equation are the values for the amplitude, frequency, for the phase shift, and the vertical shift? And from there, I'm going to get a value for the amplitude. We're going to work it out to figure out what the period is, the phase shift, the vertical shift, and I'm going to draw it. I'm going to draw it by hand. And then I'm going to confirm it with my calculator because I'm smart. So you look at it and you're like, okay, A, that's 3. And the amplitude is that when I take the absolute value of A, so the amplitude is 3. It's from whatever its center line is, it's going to go up 3, it's going to go down 3 from there. B is sitting right there. That is, the frequency is 2. Okay, the period can be found by taking 2 pi divided by b. So we're going to take 2 pi divided by 2. The period is pi radians. So we'll get one wave in pi radians. H, well, the form is x minus h, and so h is pi. And so the phase shift is to the right, pi radians. And then the vertical shift is hanging out here, and the vertical shift is +1, and so it's been shifted up 1 unit. And that's all the things that we've done to this one cosine function thingamabobber. Okay, I'm erasing this, so pause it if you want to write it down. My suggestion for getting a good sketch of this for starters is, knowing that this is cosine, well, I guess I can't really relate to that anyway. Here's what I'm going to do, okay? What I think tends to be easier than using the magic paper, though the magic paper is good. It'll be useful if you're doing your homework to have the magic paper, but here's what I would do. I would go ahead and I would draw in, oh, golly. Draw in a sine curve. Doesn't have to be pretty. Mine obviously is not pretty. And then I'm gonna put in like the details around it. That is, I'm gonna kind of start with the vertical shift because I want to know where the center line is. I've taken the picture and I've moved it all up 1 unit. Like the center line gets moved from 0 up to 1. So I know that this line right here, I'm going to put a scale on it. That's 1. Next, I'm going to look at the amplitude, and I'm going to say, well, it goes up 3 and down 3. So it goes up 3 to 4. This is at 4. It's at 1, and then it's going to go down 3 to -2. Okay, I'm just setting my scale right there on the side. Up 3, down 3. What else? Well, I gotta know where it starts, like where it crosses the x-axis. The whole picture, cosine usually starts here, but it's all been shifted that way. Pi radians, usually, let's see, that point there is now going to be at pi radians rather than at 0. So that's the next thing that I would do. And then I guess lastly is the phase shift. Oh no, that was the phase shift. It shifted pi radians. And then lastly is the period. And that's going to go through 1 cycle every pi radians. So I already set this at being at pi. And now I've got to go and say 1 full cycle of cosine gets me to 2 pi. And then I kind of draw it backwards until I get to 0 degrees or 0 radians. I know that it's going to go through 1 more cycle. And it would have like started like that. So I think I've got all my kind of business in there shifted. And then I'm going to double check by graphing it on my calculator. Okay, typed it in like this. Things where it's supposed to be. And when I did the zoom trig, I get this. Look at where that peak is to start. And I get 1, 2 good cycles in there and 2 pi radians. It goes up to 4, it goes down to -2. It's got everything that I predicted with my little picture. And then this is good enough. It's a sketch. It's got the scales labeled. It's accurate as to what all the stuff is here in this example. Let me put another one up here on the board here. Example 5. Same setup. We've done 1, 2, 3, 4 things to this problem. So we want to first identify what's A, B, H, and K from the standard form. And then from there, we're going to interpret the amplitude, period, phase shift, vertical shift, and then we're going to draw it. So amplitude's -2, and then b is right there. It's 1/2. This the standard form is x minus h, so we must have a minus pi here for h, -pi, and the k is sitting out here, plus k, so -1. So what have we done to it? Well, we've stretched it this way by a factor of 2, and then negative means we flipped the picture upside down. B, we're going to have frequency half of a wavelength in 2 pi radians, so we've stretched it out. Phase shift, we've taken the whole thing, the whole picture, and we move it pi radians that way to the left. And then vertical shift, we've taken the whole picture and we've dropped it down 1. So the first thing I want to know is kind of like what this center line represents. And if we've taken the whole picture and we've dropped it down 1, that's the first thing. This center line here is -1. And so we're going to have a 0 and 1 going up and down 2 places, and then here -2, -3. So there's my like vertical axis of how that's all going to play out. Now this is sine. Sine usually starts at 0 and goes up, but this one's a -2, so it's going to start at 0 and it's going to go down. Well, I should say I'm going to start it right here. I'm going to go down first. Down to -3, up to +1. I'm just going to put in a little bit of it first, and then I'm going to, put in the other details. Okay, so I've got the amplitude business figured out. Let's do, I guess we already did, and we did the vertical shift part already. We said it goes down 1, and the amplitude, absolute value of this, the amplitude was 2, so we knew how high we needed to go, and we know how low we have to go. Okay, let's talk about that period. Period is 2 pi over b, 1/2. So if we do our math and multiply both of these by 2, we'll get a period of 4 pi. Okay, and phase shift, -pi means we have gone to the left pi radians. So normally this would be the point because it's a -2, it starts down on sine. Because we're going to shift the whole picture that way pi radians, this now right here is going to have to be at -pi. Our original starting place just got shifted that way over to -pi. And then we go from that and we say, well, the period, how long one wave is, that would be from here to back to here. That is 4 pi radians. Now from -pi we go forward 4 pi radians and we get to 3 pi. So each section of the graph is pi radians. That means that this right here would be at 0, and then another pi radians we get to pi, and then here we're at 2 pi, and we finish off the picture by getting to 3 pi. So that's what I want to double check on my calculator. I'm going to put that in. I'm going to look at my picture and look at his picture and see if it looks what I predicted should happen. Okay, so I put in my equation just like that, and I'm going to hit that graph button. And it's long because it's doing its thing, right? Okay, now where is that on here? I only got to 2 pi, so it does kind of hit a peak over there. And it's on its way down when it crosses 0. My picture doesn't look exactly like that picture. So what did I do? Oh, it looks, I've got all the stuff and I've got it correctly labeled. So this is good enough. Maybe I'll change my window And I'll go from negative, oh, what's that, 180 up to 3 pi, which is, no, don't write in 3 pi, Spence. 540 degrees, something like that. And let's see what we got here. Up it comes. That's a really long period on that sucker. Look at that. It takes up 4 pi radians to go through one cycle. Okay, now I basically got that. I got all the details sketched out there on that. I kind of think that you should try kind of working this backwards. I think you should fiddle with the numbers and like, predict that I'm going to move it up, down, left, right. I want to stretch it. I want to squeeze it. Like, adjust those numbers and do something different and build a function rather than, strip this one out and look at all the pieces and then draw it. Why don't you draw something and then figure out what its equation happens to be. So I got here a bonus problem for you. Okay, I'm going to show it to you here. I want you to write a formula for a sine function that goes up to 3, down to negative 1, has a value of 3 at 0 radians, and has a period of 4 pi. Up to 3, down to negative 1, value of 3 at 0 radians, and has a period of 4 pi. You send that in with your homework, and you get a bonus point there. But yeah, you just got to fiddle with it a little bit until it does what it wants you to do. And you have 4 things to fiddle with. The amplitude, the frequency or the period, the phase shift left or right, and the vertical shift up and down. Fiddle with those 4 parts until the graph goes where you want it to go, and then call it a victory. Okay? That's kind of bringing those 2 ideas together. You got scale changes and you've got translations. If you need some help with that, let me know. I'm available. I'm here for you.